Hi, this is Scott.
And this is Josh from Leak Dev. It's live stream. Did I say that right?
Yep, exactly. Okay.
All right. So what do we do in this series, Scott. Don't worry, I promise I'll get this right eventually.
We can always just cut it out.
We're not cutting this out.
So we're going to pick one problem from this most frequent asked question on LeetCode. Numbers of islands. So I believe I get asked these exact questions at a few companies actually. How about you, Josh?
I think it's pretty common actually in phone interviews a lot. I think it appeared for me at least once in Google. I know that for sure.
Given an m by n array, two-dimensional grid of a ones and zeros, 1 represent land and 0 represent water, return the number of islands. An island is surrounded by water and is formed by connecting adjacent lands of horizontal or vertically. You may assume all 4 edges of the grids are all surrounded by water.
So now that we're on the whiteboard, let us draw our little matrix. I see you're already drawing. Anyways, so the top left corner is 0, 0, and the bottom right corner is 2, 4. Or I guess 4, 2 if we're going for a x, y coordinates. So, any ideas of how you might try to solve this problem? You remember this from, I don't know, God knows, like a year ago since I last heard of this problem?
Yeah, so a good way to start, we need to at least traverse each of the element of the two-dimensional array. So we need to do a nested for loop. So for example, we can have I and j as we commonly use in programming. I as in a pointer that controlling the y axis, and j could be the pointer that controls that x-axis.
So in a way, it's kind of like this problem is kind of like a graph problem, right? Right.
That's a good point. Yeah, this is basically a graph problem. So you can think of it as a breadth first search. So for example, if you go to index 0, 0, which x0, y0, which is this one right here, I'm going to go ahead and mark if we want right here. And then we want to traverse all its neighbors by go down and go right and go up and go left. But this is indexed out of bounds, so obviously we're not going to go. And then as we go, we have to mark these elements as visited. And we
right, like a classic, BFS, DFS problem. You visit the node, but then potentially you can go back up into that same node you came from. So to prevent that, we have to have for those of you familiar with a BFS, DFS, we have a set that keeps track of all the nodes that you have visited.
Correct, yes.
So we can do something similar here.
Yes, and then you can think of when you go into this element, and we have to just recursively repeat the process over again.
Cool. So now that we're talking about this, some of the memory is kind of coming back to me about this problem. There are actually quite a few ways we could mark the locations that we've seen. One way would be if we had another array of booleans, for example. Thank you for drawing that for me. Where we would mark true of all the locations that we've seen already, and then or been to, and then false if we have not. And then every time whether we just visit normally or do our DFS traversal in our matrix, we would just mark it to be true.
Right.
However, that would give us a space complexity of, I guess, basically of n, which is the whole entire matrix that we're given. A smarter optimization that we could do is to actually use the array itself, the grid, the matrix itself, to keep track of the locations that we visited. So what we do instead is, while we're going through the array, the matrix, we would, for every location that we visited, we can actually set the value to be 0. And then if we ever see it again, we know that 0 is water, and so we shouldn't continue going through our graph algorithm. So we'll just stop there. which is basically the equivalent of saying we've already seen this location before, so we're not going to continue. So we'll just continue going through the rest of our indexes in our matrix until we have visited every single one that we can that's connected.
Right, exactly.
And I believe this is called flood fill. I'm not 100% sure.
Yeah.
You know?
Yeah, I'm not sure what's the right term is.
All right, well, we think it's flood fill.
Yes.
If it's not, leave a comment.
And basically, if you have the option to choose 1 and 2, I would recommend going for option 2. If choosing option 1 would involve like having to manage a second array, because in it
actually, you know, that's a
yeah, because unless the interviewer specify, and then I would optimize for completing the problem first, because in an interview you have a time limited bound to, for example, have 40 minutes or 35 minutes. Yeah, let's go ahead and get have something on the coding board. Alright, so we're gonna start off like we talked about earlier. So we want to have some sort of a helper function to go ahead and kind of recursively backtracking, marking all the island that we visited. So it's probably gonna be just returning void, and we can call it num islands helper. Of course, it's going to be taking the grid itself.
I like the dark mode you have on.
Yeah, it helps people when they're at night seeing this. Maybe this is kind of like Bob Ross, and I'm going to watch this and go to bed.
Gosh, I know we're recording this in the evening.
Yeah.
Actually, on that topic, do you think we want to maximize the screen a little bit? I think it might be a bit too small for our audience. I have it on maximum my screen, so it looks nice, but
is this help?
I don't know. Yeah, I think it is. Can you do one more? Yeah, there we go. There we go.
One more?
No, one more. Yeah, I think this is good. Let's stick with this for now.
Okay, so we have, like we said earlier, so we have a y.
Yeah, our y is the up and down, and if we're going through a matrix, a typical the outer for loop always goes through the rows in our grid, and then our
y plus plus. Yeah, we can call it row and column. Maybe it's more clear, right, Josh? What do you think? Okay, we can stick with.
Yeah, I agree.
Row and column. Okay. So now we have a column.
Right.
Int column less than.
Yeah, we don't need the int there.
Yeah. M and N could be. Yeah, we should do this actually. Grid. Is it row and then
row?
We don't need this. Row.
Yeah. See, you're working in a different language.
Yeah.
Is it C++? Did C++ deal with that? I can't remember.
Yeah, no. I was thinking about Java, a list instead of a native array.
I see. Yeah. An object. Yeah. C++. And also we have a you did int column is less than grid.
Am I missing ups?
No, yeah, you add an extra int. Yeah, there's an extra int.
Oh, yes.
You did. Yeah, there you go.
There you go. Hey, awesome. And initially, if we can't find the answer, we're probably gonna have a 0 as our count.
Right. Yep. Right,
Oh.
we gotta always have a way to keep track of our answer.
So if our grid is equal to, this is our row and this is our column. If it's equal to 1, we can increase our count by 1.
Yeah, our count, right?
And then we can
start our flood fill algorithm. I'm gonna keep saying it's flood fill until someone tells me it's wrong.
So I'm gonna pass in row and column. I'm gonna use the concept of row and column.
I think it's the other way. Oh yeah. Okay, that's fine then.
Row and column. So the first thing we should probably do is we want to make sure our values are inbound, right? So
that's actually very common if you see a lot of matrix problem, matrix of BFS DFS problems. always want to make sure that you're inside the matrix.
Yes.
Because you'll see later when we're jumping around or when we actually implement the algorithm why we might go outbound.
So one thing I like to think about this like a mathematical way. So you can think of it like this is a lower bound and this is going to be our upper bound. So the row has to be greater than or equal to 0, but the row has to be strictly less than our grid length. And our y has to, oops, sorry, our column.
Or it's column, right?
Column.
Less than equal to, yeah.
And then our column again has to be less than our grid row dot length. So if all of this condition have met, let me get more space.
We just it's well, if this all met, then it's inside. Then you want to, and this is when we go through our recursive.
Right. Some people like to invert their function. We can do either way. Invert function as if it doesn't meet this condition, we can go ahead and return. You want to do that, Josh, or should we? Doesn't matter.
I think, I mean, we already have this. Let's just keep it as it is.
Okay.
With this way, I think one nice thing we do, I assume what you're gonna do is you're gonna say if this grid roll is inside is a 1.
Yeah.
We will do our DFS. But if we're doing it this way, I think we can actually include that inside our first if statement, right? Save an extra if statement.
Okay. Yeah.
It's a personal nitpick. It's not that important, but
yeah, we can. That's a good point. So yeah, and also we probably only interested.
Yeah, we're only interested in the if the grid and row is 1.
We are running out of space, so what we can do usually we can do this.
Oh, you care about pretty syntaxes, huh?
Oh well, it's easier to see a little bit for because we have limited in screen size.
Yeah, we did kind of increase our screen resolution.
Yes. So like we talked about earlier, what happened is if we are inside of this condition, we can go ahead and mark our neighbors up, down, left, right. So we go ahead and
not a neighbor, ourselves, right?
Oh yes. First we want to change. So yes. Sorry. We want to change ourselves.
Yeah.
Oh.
It's a char, not a 0, by the way. I can't wait for the day you start nicknaming me on my code when it's my turn. Sure, it's not easy.
Yeah. So we want to go up.
Right, so
1. We want to go down. We want to go right, and we want to go left.
It's a 2 plus plus and minus minus, right?
Actually, we want to do +1.
Oh, yes, you're right. It's +1 because if we actually, well, it's an integer, right? So actually, we did plus plus. Well, it'd be wrong for a different reason.
Yes.
We would pass in the value and then we would increment it.
Correct.
Versus if we just did plus plus row, which then would increment it first and then pass in that new value.
Correct. Yes, like Josh. Yes, exactly. So let's kind of look at our code. Okay, so
so confident already, huh? You're not even declaring to me that this is complete.
well, we kind of go through it one line by line together, right? So I want to make sure that it's actually.
I mean.
Okay, so we
I do agree with you.
Start with the very most outer loop. We have a row, we have a column, and we check a row or column is equal to 1. Go ahead and increment our count of results. Otherwise, we'll call our helper function. Pass the row, we pass the column, and on the row and column, we check it has to be in between the bound of the row and the bound of
it's our matrix.
Correct, and the bound of column, and it has to be equal to 1. And then if that's correct, then we change that to 0, and we go
right. That's our visited thing. Well, how we mark. Never seen something.
Yes. This is our up. This is our down, and this is our right. We just take column +1 and similar. Going left by taking column -1.
Right. Right.
And
And
I
that's
think this is
yeah.
it. Should we run run it to verify? It rarely works on a very first try, but we can always try.
Wow, so this is how you gonna tell this here. I'm just gonna send in my code and call it good. Fine, press that button.
Hey, it works.
Wow. I mean, I had a feeling it worked, but wow.
This is awesome. Should we try this one out?
You wanna try it out? You just wanna press the submit button?
No, let's try it. Let's be safe. Should we cover all
I'll
the
be safe. You would press that run code button. Can't get any worse than this point on.
Alright. Did we get 3? Okay, now let's hit submit. Perfect.
Well, hey, we did it.
So should we walk a few debug cases, or?
Yeah, I think that'd be great. I feel like we might have not done a great job explaining the why we have the we call the num island helper row +1, row -1 +1, and column +1 -1.
Sure, let's run through a few cases. So a row is 0, a column is also 0, and the very first.
So we just entered our for loop.
Correct, and we're gonna go ahead and peek at the grid of 0, 0, which is gonna be this one. So is it equal to 1? It is. We increment our count by 1. Becomes at 1.
Because we know for sure we found one island at this point.
Correct. And this is where we recursively marking all of the neighbors. Is that the correct word?
All of the other neighbors, yeah.
Yes.
Yeah, we want to find all of our other land.
Right. We want to make sure that we are still within bound before we go ahead and check the array. Otherwise, we might potentially get the out of bound exception.
Oh, well, potentially, we will crash if we do. If we
Yes. All right, and we also need to check
in
that.
This case.
Correct. We also need to check that the value of the current element is equal to 1 before we interested in changing it. Otherwise, we're hitting water.
If it's 0, yeah, then that means there's no point exploring. We just go back to our previous stack.
Yes.
Stack frame.
Yes.
Our recursive stack frame.
It will make a little bit more sense when we get to that explanation. So we can step into it. It is equivalent to 1. So we're gonna go ahead and change this current position to 0. So now
Watch
it
the
is
magic
0.
happen.
And
Bada bing, bada boom.
And this is what Josh talking. So we're gonna go ahead and go to the neighbor, which is we're taking the row plus 1. So in this case, it's actually going down. Down is equivalent to up. In computer science, that's
it's a you know, it's odd. It's like I've been doing this for so long. It just seems normal to me now.
Yes.
Anyways, yeah. So we're gonna step into it, and we're going to see.
We're checking out grid.
See our rows now is if you look in the debug in the bottom left, our row is now 1 and our column is 0.
Yes. So we step in again, and it is still a 1 over here. So we're gonna change that into a 0. And we're gonna go to row number, the second row.
2.
Yes.
Yep.
So
and we'll see that it's 0 already. So it'll be interesting to see what happens at this point.
So now we at.
So hopefully you press the other button.
Yes, so now we at row 2, column 1.
Row 2, 0.
Oh, sorry, row 2, column 0, and this element is 0, so it doesn't match on this case over here. So we're not gonna go into that position. So we're gonna skip over. And this is where Josh talked about earlier. It's gonna collapse the stack. So we're gonna go back to the case where row is equal to 1.
Yeah, we're gonna go back to the function I called it, and here we are.
Here we are.
And now here's the part where setting the grid row column to be 0 is very important to us, because before we came when we were at 0, 0, row 0, column 0, and now we're going back to, right now we're at row 1, column 0, and right now we're going back to row 0, column 0.
Correct, yes. And we gonna go ahead and step into it. And now we're back into this position over here, but we previously have already marked it as 0, so we changed an island to a water. So now it's gonna go ahead, it's gonna fail on this condition check, So as we can see, it's not going to go into it. And yes, this way we're never going to have a infinite recursion.
Yep.
So this, we are going to the right hand side. So we are currently at this row, the second row, index, which is index of 1. Step into it. Now,
yeah, and I think it's, yeah, now we're at 1, 1. It's pretty much the same thing. We're going to kind of skip through it, but we're going to set it to be 0. And then we're going to go in the 4 directions, up, down, left, right.
Correct.
I don't think there's anything too interesting, because if we look at the, well, I mean, there's nothing too different from what we've already seen. We're going to go up 1 to row back to row 2, and there's not going to be any, it's going to be water, so we're going to skip that. We're going to go back, and so I think we just step over this. It's probably nothing too interesting to see. Row -1, we're going to go to row 0, column 1. That would set that, well, it was a 1, but now we just changed to 0. And yeah, nothing too interesting. I think the interesting part is once we finish going through row 1, column 1, and go back up again, we're going to see what happens if we hit an array outbound exception.
Right.
So I think if we just keep stepping over, Scott, I promise, one day.
Okay.
All right, so we're out. We're back at 0, 0.
Yes. So now we're gonna go to the right hand column, but it's already done. So we step over it, nothing happens.
Yep.
This is it's gonna be indexed out of bound. So if we step in,
yeah, so it'll be interesting.
Should we step into it?
Yeah. Yeah. Absolutely.
All right. So now we have column of -1, so it doesn't pass this domain check. It's gonna fail the column check on this one over here. This part over here.
And if we don't do this, we will crash when we try to access the matrix.
So now let's go back to the previous stack.
Yeah, and that's pretty much this algorithm in a jiffy. We just explore every single possibility.
Yes. All right, I'm gonna go ahead and run through all of it, and we are finished.
Yep. Yeah, and it's important to note that if we don't find it, if there are multiple islands in this problem, we'll just continue iterating through our matrix until we find the next one.
Correct. Perfect. Is there anything else we should say to our audience?
Well, there's always if you guys like the stream that we're doing and want to see more of this, please do like and subscribe. And yeah.
Well, let us know what you want to see next.
Yeah, that's my sales pitch. Yeah, that's a good point. If you have any, please tell us what you want to see in the comments below. Otherwise, we're just gonna keep going through the list of most frequent interview questions that you might run into in a interview.
Awesome. But thanks a lot. This is Scott.
Yep, so that's it. This is Josh.
Signing out.
And we're gonna sign you off. There you go. We get this right next time. All right, thanks everyone.
Thanks. Bye.
Bye.